So there's good news and bad news. The good news is there's no new formulas. We've done all the formulas. In fact, all the formulas were last week because the loan formula is the same as the payout annuities formula. This video can be a little tough though, depending on where you're at, because there's no real formula for it. So you might have actually appreciated a new formula. So this has to do with remaining loan balance. So let's say I buy a house and I have a 30-year loan, but after 5 years, I have to move for whatever reason. Maybe for whatever reason, I have to move. So the question is, what's the remaining loan value? And, what is my equity? How much equity do I have? And that's what your activity this week is actually going to talk about a little bit, as well as not having to move, but it's about like refinancing and stuff like that. So that's kind of cool. I enjoyed doing it anyway. So that's what we're going to talk about here. So it's a little confusing because when I'm making monthly payments for loan, a large amount of those monthly payments are actually not going towards the value of the loan, but it's going towards the interest, especially early on. You're paying a lot of your monthly payments go to the interest because the more there is, the more interest there is, kind of a deal. So when we're paying things off, I've paid the bank a bunch of money, but the loan is actually probably not much smaller initially. We'll see kind of how that works with some of these problems, because only a portion of the loan payment goes to the loan balance and a portion is applied towards interest. All right, so again, as an example, as a warning, we got skull and crossbones. Even if we're making $1,000 per month payments, in a year, that's $12,000 of payments, but a lot of that actually is going not towards the loan balance, it's going towards interest. So the loan balance is not just lowered by $12,000. All right, and we're going to see how that kind of works with example 7.12. Example 7.12, we have a mortgage at a 6% annual interest rate. We're making payments of $1,000 per month. How much will the loan balance be 10 years from the end of the loan? So we're just going to calculate loan balance for 10 years. We're going to use the same formula we used in the last one. Okay. The loan amount is the monthly payments times 1 minus 1 plus R over K to the negative NK divided by R over K, just like before. So if there's 10 years left on the loan, that's just going to be this 10 right here. And we'll talk a little bit more about where that is after this example, where that comes from. Okay, so monthly payments, $1,000 per month. 1 minus 1 plus our interest rate, which is 6%, divided by K, which is monthly payments. So K is 12. To the negative N, there are 10 years remaining. K is still 12. And divided by our interest rate over 12. And again, if you have this typed into Desmos from before, you can just update the numbers. This is now $1,000. This is now 6%. This is now 10 years. This is now 6%. And then we go to our notes and go back and forth. Check to make sure that it looks exactly like what we want it to be. And we've, when there's 10 years remaining, we have about $90,000 that's left. $90,073.45 is how much is remaining. So that is our answer to this question. But sometimes it's a little bit more complicated. Sometimes we don't know our monthly payments. Sometimes we might know our monthly payments. And that's what it's going to look like in the next page. So in general, when you're looking at a low blast, pretend that says loan balance. When you're looking at a low blast question, you're going to need the monthly payments. Sometimes this will be given, sometimes it won't. Oh, I'm making a joke. I'm not showing you the notes. But yeah, we got this thing up here. All right. First step is going to be find the monthly payments if it's not given to you. and then calculate the remaining loan balance based on the remaining time. Remaining loan balance, remaining time. There's that connection. So 713, Emily bought a car for $24K 3 years ago, and it had a 5-year term with 3% annual interest. Much lower interest rates than some of the people we've been talking about. How much does Emily still owe on the car? Okay, so we need to find the monthly payments first, right? Step 1, monthly payments. We did that in the previous video. Same formula every time. I love copying it down. Let's copy it down again. D times 1 minus 1 plus R over K to the negative NK divided by R over K. Now we're looking for those monthly payments. The loan was for $24,000. Monthly payments, we don't know. We're going to have to calculate this numerator value, 3% annual interest rate, so K equals 1. And 5 years. Eventually, we're going to say there's 2 years left. But right now, we're looking at the monthly payments for the full 5 years. So we type in this formula like so. And just like we've been doing a lot in the last couple of weeks, we use our calculator to make it a little easier to solve for D. Let's type in that number in the numerator and see what it is. That number in the numerator is going to be 1 minus 1, 1 minus 1 plus 0.03 divided by 1. Raised to the negative 5 times 1. That number in the numerator is 0.1373912. And the denominator is just 0.03. Multiply both sides of the equation by the reciprocal of this fraction. 0.03 times 0.13739112. They will cancel on this side. We can think of 24,000 as 24,000 divided by 1. And write these numbers over here again and use a calculator to figure it out. Because the right-hand side only has a D. The D is going to equal whatever this left-hand side is. This left-hand side is 0.03 divided by 0.13739112 times 24,000. Now look at what happened when I typed this into a calculator. 5,240. My original thought was that's too high for monthly payments. But remember, what are we doing? We're looking at, we calculated annual payments. We're trying to find monthly payments. What's the mistake? The mistake is that I used K equals 1. So if you write down this as a monthly payment for your car, you must be buying a really nice car. Okay, so let's go back a little bit. You can press Control Z to undo. Let's go back to this formula. We don't have annual payments. We have monthly payments. Okay, so change that a little bit. And now this number should actually be very, very similar. It's going to be 0.13913,089. But the other number is the one that should change a little bit. The other number was 0.03 divided by 12. That's 0.0025. And we're multiplying that by 24,000. Small little typo here in the first one that's making things a little bit more complicated. So we have 0.0025 divided by 0.13913089 Multiply that by 24,000. And now we get a much more reasonable monthly payment. Before we calculated the annual payments, but this is the monthly payment that we wanted. Okay, so it's going to be $431.25. And that's one advantage to these financial application problems, right? Is you can go through and say, oh, wait a minute, this doesn't sound right. I think I may have typed in something wrong. Right, so these are our monthly payments. That was just step one to find the remaining loan balance. Monthly payments, good. We found out our monthly payments, 431. Remaining balance is using the original loan formula again based on the remaining time. So it was 3 years ago, and it's a 5-year term. Now there's 2 years left. So now we go back into this formula, which again should have 12s here. Go back into this formula, put in 2 years left, put in the monthly payments. Now we'll have our answer. So let's do that. Type in the monthly payments into the loan formula, 431.25. Our interest rate is 3%. There are now 2 years left. Interest rate is still 3%. So there is about $10,000 remaining on this loan. It's how much we still owe. Which again is going to be having interest on itself. So Emily bought the car for $24,000 3 years ago. There's 2 years left. $10,000 is remaining. And spoiler alert, she's spent a lot more than $14K on this. That's the end of this problem. We have one more problem to do. But I just want to kind of just off to the side, just for fun. How much money has Emily actually put towards this car in these 3 years? Calculate this out real quick. 431.25 times 12 times 3. Emily has already paid $15,000. So you'd think there'd only be $9,000 left. There's actually $10,000. So not a big difference because of this low interest rate, only 3%. With a bigger interest rate, that difference is much bigger. Anyway, that's kind of it's not necessary, this little aside, but it's kind of interesting. I'm out of paper. I need to get more paper. And then we'll do the last example of this video, okay? We are going through a lot of paper today. So a friend bought a house 15 years ago and took a $120,000 mortgage at a 6% interest rate for 30 years. How much does she still owe on the mortgage? And then there's a follow-up. So we have to do the same steps. Find the monthly payments. So we're going to copy this formula down again. This is example 714. Copy the loan formula down, and we're going to input the right numbers this time. Monthly payment, we need to know this. The original mortgage was $120,000. D is what we're solving for. Interest rate is 6%. Divided by K, we're going to be making monthly payments. All of these are going to be monthly payments. 30-year mortgage, K is still 12. Divided by the interest rate, R, over K. We'll type these things into a calculator so that we can solve. First, let's type this number into a calculator and see what it's going to be. So that's going to be parentheses 1 minus parentheses 1 plus 0.06 divided by 12. Raised to the negative 30 times 12, like so. This is 0.833958. And the denominator is again 0.005, I believe. And now we just need to solve for D. A little bit more algebra. Multiply by the reciprocal. They cancel on the right. Multiply by the reciprocal on the left-hand side again. 120,000 is also the same as itself divided by 1. And this left-hand side is going to be our answer for the monthly payments. Okay, not our answer to the whole question, but the answer to part of the question, the first step of the question. We're going to find that our monthly payments for this mortgage are $719.46. That was step 1. Now remember what step 2 was. Scroll up. Calculate the remaining loan balance using the same formula, but this time based on the remaining time of the loan. So it was 15 years ago, so there's 15 years left. Okay, 15 years ago means 15 years left on a 30-year loan. So we go all the way back to this formula again. And you really don't have to write it out as many times as I do, but I really like writing it out every time I use it. I find it's very helpful to keep things organized and correct. Now we use those monthly payments that we calculated and fill in everything else. Interest rate is 6%, K is 12. Now there's 15 years left, so change that N to a 15 here. And we type this whole thing into a calculator again to find what is the remaining loan balance. So again, luckily we already have this formula, this calculator used. Just update our monthly payments, update our interest rate, update how many years are left, update the interest rate again. The remaining loan balance is $85,258.54. But we're really going to drive this home soon, but take a moment to appreciate this. The loan was for $120,000. We've been paying it for half of the time, 15 out of the 30 years. We've been paying it off for 15 out of the 30 years, and it's still $85K is left. Because we've been paying so much for interest at the beginning of the loan. And at the beginning of these larger loans, you really are paying a lot in interest. So let's look at the follow-up again. How much has your friend paid of the loan? And compare this to your friend's total payments. So paid of the loan is just the difference, right? 120K, 85K. How much has she paid on the loan? That difference. She's paid 120K minus 85,258.54 off the loan. Let's use a calculator and figure that out. She's paid $34,741.46 off the loan. But I guarantee she has given the bank much more money than that. What are her total payments? Her total payments in these 15 years are monthly payments of $719.46 every month for 15 years. She's reduced the loan by this much. But how much money has she spent? $719 46 times 12 times 15. You ready for this? She has paid the bank $129,000 and reduced the loan by $34,000. Because early on in the loan, so much of your payment is going to the interest. That's why this interest rate is so important. That's why how much you can pay is so important. Okay, this is crazy, right? So keep this in mind. And then the activity this week incorporates a little bit about this as well. All right, good luck, have fun. Happy news. Happy home buying. Anyone want to buy a home? All right, bye-bye.